Okay, let's get started. Start with company update.
Introduce yourself. Yeah, right. Chris. I mean, I've been talking on these meetings before, but yeah, I'm doing a work trial this week. Yeah, cool.
Great. So we launch Red V2.
Yeah, we launched Rev V2. We haven't sold one yet, so we'll see if anyone buys them. We made like 4 of them. I have one in my office. It's pretty nice.
Oh, if you click on the link, it goes to a tweet.
If you click on that top link, yeah, it goes to just the Twitter thread where I did all the benchmarks and stuff. I don't know. If anyone out there has like a reputation for doing this and wants like to do LLM benchmarks, I'll give you SSH to the machines. Dylan never reached out about that. Dylan Patel. No. They got a lot of stuff.
Hey, great. Yeah. So two main things for the meeting. One is about Karma. One is about the Llama ML perf thingy. So we can quickly go through the Karma stuff first. Karma after probably being annoyed by me poking them all the time, they upgrade the Tinycorp version. So we caused some regression to OpenPilot when we switch to Renderify, and now we are in a state that it runs okay for them, but also many things that were regressed by Renderify remain regressed. Notably, a lot of comp speed, both forward and backward are slower. That's why Beautiful M or ResNet is slower. CFAR is also slower. So that's
Yeah, I think it's indexing stuff.
yes. So it's definitely indexing stuff because the rules we comment out is something to the indexing, but not clear exactly why.
Yeah. I was looking into it. It wouldn't be much work to add egraphs on top of what we already have. Egraphs don't actually need, I thought they needed a different kind of rewrite rule. They don't. The only thing egraphs need is a promise that any rewrite rule that does trigger is invertible. So if you've substituted node A for node B, you could also substitute node B back for node A. And that's always safe.
Mhm.
Which is like true for all the symbolic rules. So we could actually probably write like an 100-line egraph saturation engine. I don't know. When you look into symbolic more, if a lot of the problems just come down to like finicky rule order application stuff, then maybe we consider doing it with egraphs.
I don't think this one is ordering, but I would know better after I look more. Because
Okay.
I also try to simply like flipping something for the order to see if it happens, make both work. It didn't work.
Yeah, no, I don't want to waste a lot of time. Like, oh, we got to get this order of these rules exactly
Yeah.
right.
So I don't think it's that. I think it's a good opportunity to also see if we can further clean up the indexing a bit.
Yeah. So the other thing too is like it does kind of look like indexing is this separate kind of like we use the rewrite engine for a lot of stuff.
Mhm.
I'd be okay with like only enabling an egraph saturation on the indexing rewrite. And yeah, it'll make the indexing rewrite a little bit slower, but I don't think it's very slow anyway. Like most of the rewrites are not indexing. So even if we get like a 5x speed hit to something that's 5% of the time, it's fine.
Okay.
But do you see what I mean by like egraph saturation?
You mean writing the egraph algorithm?
Yeah, the algorithm is simple actually. It's not basically what you do is you just like apply every rule every time you figure out which rules you can apply and you apply every rule and then you use a clever data structure in order to like not have to store the exponential number of graphs.
Yeah, but how do you pick what you want at the end?
So yeah, there's different algorithms for that, but actually it almost looks like choice. It's interesting how much it looks like choice, right? Because you can like encode exponentials in everything where you can say, well, okay, at this branch you can go, any of these three things are equivalent. So it's just equivalence things at every node. Um, then at the end, you can run, I haven't looked too much into that, but you can write like uh, evaluation functions that run in the runtime of the number of nodes, not the number of graphs.
Mhm.
But yeah, again, if this is something you want me to spend time on, if it turns out to be ordering, because egraphs will totally just fix the ordering stuff. And I think we're going to have to go there eventually. But if the bug turns out to be something else, or then we can do it later.
Yeah, I will know better after I look this more, so we can
But
decide
yeah,
later.
the most exciting thing I learned about egraphs is that our existing rewrite rules work totally fine. That's a
Uh,
limitation. The reason they don't work in egg is a limitation of egg, not a limitation of the fundamental idea of egraphs.
so that's the speed front and semi-related. I think Kama also expressed that they are interested in the HVAC decode.
Yeah,
So
Nimilja, what do you think about that? What do you got? What do you got planned for this week?
Yeah, actually, I plan to look into these.
Great. Yeah, I think Kama would be super happy with it.
how do we know if we support it well? Is there something that we can like try test wrong?
Oh, it's the simplest thing to test. Just decode an HVAC. Maybe some throughput tests. We can definitely. There's tons of examples of Kama HVACs online we can try. But we should also test it with other HVACs too. Another victory for Kama is they do this resizing thing on the device, and they have a custom OpenCL kernel for it. And now when you write it in TinyGrad, it's just fast. Well, if you write it as a 2D indexing kernel, it's not fast. But if you flatten it first and then you index in 1D, it's fast.
Why isn't that fast for 2D? Do you know?
I have no idea. I think we just like didn't write the. I think we just didn't write the rule.
Interesting.
We can fix that, but it's also not a big deal to flatten it and reshape it. It's free.
Yeah, I update
Yeah.
a few tensor methods to use arange as building blocks instead of movements. I think it's identity metrics and the triangular thing. Those make the kernel itself a lot simpler and faster.
Great.
So maybe
Yeah,
we can.
we should. Range is basically a movement op. We should feel free to use it.
So the main difference is if you don't use it and later the thing simplify into ranges, in UUp level, that range will be reused. So think about when you do identity metrics, it's either like your x equals to your y, that's your identity. But if that range is reused, you end up having a much more complicated expression than just GIDX0 equals to GIDX1 because that is reused.
I see how simple the A range one is. I struggle to even think about what the movement up one is. Like I kind of know it, but yeah, it seems a lot more complicated. I think using A range is fine.
Yeah. Okay. Let's comma. Then we have MLPerf llama. There was a stop function that tried to see what's the limit that we are getting now on llama training. I think we are 2x off in terms of memory usage.
Yeah, so I think there's three parts to llama training that can be worked on in parallel. One is getting 8B llama to train, which should work with what we already have. Like just making sure that all our data loading's correct, that we're achieving the required loss. It's nice that it actually is an MLPerf thing. So I think getting the 8B is one thing. Getting some form of flash attention kernel. The sooner we can do this, the better. Like the sooner we can get any flash attention in there, because that'll let us do the long context on a single GPU. So even if we do, by the way, Causalin has this cute thing where you can use custom kernels if you want to just write arbitrary like HIP code by using the custom UOP, which again I think is totally fine for just getting some sort of flash attention in there as soon as possible, so we can start training 8B. So there's the 8B training. There's the fast kernels, which is like getting fast flash attention first, and then fast gem second. And then there's the outer world stuff. So I spent a couple hours reading how JAX does scan and 4i. They're both differentiable. So it depends, actually. JAX has a whole lot of code paths to deal with this. In the simple code path, they will happily differentiate scan, and the derivative is pretty simple. What you do is you convert the range. All we basically need to do is substitute the range on the forward pass with a gradient range on the backwards pass, and then it mostly just works. You can't use the same range on the forward pass as the backward pass, because then it's then your the range already ended. So you just replace the range, and then like the gradient rule is simple. So that's cool. As soon as we get a scan operator that works. So I should have that by the end of this week. That's my main focus. And then we'll be able to write these things. It'll be the same thing, but it'll just be very fast to in Python time, because we don't have to differentiate this massive graph. And we don't have to rangeify this massive graph, which are both slow. But yeah, if you think we can get any blockers to get 8B training on par with the MLPerf rules.
Not sure. I would test with now later today to see what's the current memory usage, even for 8B. Last time I checked, it was pretty big.
Parrot, you think you could have a flash attention kernel in any way, shape, or form up by the end of the week?
Yeah, that should be fine. I'm probably can actually have a hip one, maybe by today or tomorrow.
Great, yeah. I mean, even if it's the slow one from the 4090, though, that one's good too. It's just important that we get the memory usage correct.
Yeah.
I mean, anything will be faster than using the massive amount of memory anyway. So, yeah, whatever we can get in. But let's definitely. I want this training by the end of the week with a custom flash forward and flash backwards to not waste tons of RAM. And also, we need that so when I'm writing the scan thing, I make sure it still works with the. It's a little bit tricky on the scan derivative. So the naive way to write it, it's going to recompute everything from the forward pass. So yeah, I mean, in some ways that's gradient checkpointing for free. In other ways, it's not explicit. So yeah, I mean, I think that flash attention forward saves the softmaxes. I have to make sure that we have a way to do that.
Another thing that will help is FP8. So I haven't checked the submission details. Likely they have FP8.
Video one has to be FP8. So it would be great if there's just a recipe we could copy. Though there's a chance it's not FP8 and it's block scalars.
Yeah.
Yeah, if it's block scalars. Yeah.
Cool. Sounds good. So some kind of custom doesn't need to be slow, but need to be good on memory, flash attention forward and backward, then training Llama 8B.
Yeah, that would be great.
Next,
Okay, so
oh, sorry, go ahead.
I mean, things that I definitely want by the end of the year. I want like custom flash attention and gem working that are decently fast. I want 8B training and hitting the ML perf target. And I want 4 or 5B having a Python time of like under, 20 seconds or something we can iterate on. But yeah, if we can. Go ahead.
No, I was going to conclude the point. So you go ahead.
Oh yeah, no, it's just basically that. Like, this is where we got to be by the end of the year. I think we can do it. We got 6 weeks.
Oh, sounds good. Next is SQTT with the vibe parser.
Yeah, I can talk about my side on SQTT. I merged the
Can I hear you?
Can you hear me now?
Yes.
All right. I can talk about my side. I merged the timeline. So if you run with SQTT equals 1, you can see the timeline in the x-axis is the cycles of all the waves that are launching.
How did you sync the cycles to the time?
Oh, it's actually just cycles on the x-axis.
Oh.
I don't sync to time. Yes.
Oh, I see. So it's a separate graph. It's not on the main profiler.
It's not on the main profiler.
I think that's fine, actually. I think that's mostly fine. So it's cool. If you got something like I can't run it right now on my Mac, but I'll try it later. So that's like you're saying that's like when I click on the kernel, it shows me like how all the waves dispatched on like a separate copy of the profile timeline.
Yeah, there's a picture of it on the Viz channel if you wanna look at it.
Yeah, I was looking at it. I didn't totally follow where those things were, but I see. Okay, cool. So you click on the kernel and it shows the waves. Yeah, that's great.
Yeah. I actually think it's better because when I normalized it to real time, it looked too small. Like it's so granular that it has to be like a clock scale.
Yeah, I mean it's super fast. So like this is going to be you got to think about like what the order of magnitude is of the number of waves we're going to do. The order of magnitude something like 10,000. Is it fine? Can our profile like that's reusing the logic from profiler, right?
Yeah, everything is reusing.
Great. I think this is the right move. I think we shouldn't try to shove it onto the top graph. I think that's a lot more than we need. Like if anything, the only thing we might want to put on the top graph is some kind of checkpoints, but I think those should be in GPU time anyway. So yeah, totally fine with it being a separate thing. And yeah, like order of magnitude, can we handle something like 10,000 waves?
10,000 waves, I think so. Yeah, that should be fine.
Yeah, it'd be really cool. Like if you could like click on the wave and see each one and then like average some statistics about the instruction, but also be able to look at each individual one. You get so much information from these GPUs.
Did you manage to do the reversing?
Oh, did you try it?
I mean, I looked at it a little bit. I can't really decode it per se.
Yeah. I got it mostly.
But there's no like stall in the.
Well, no, there's no
stuff
stall.
that they say. Yeah.
There's no stall. The big breakthrough I made was being able to. I got all the names of the things from the just by excluding them one at a time because there's a named enum to exclude them. So there's not going to be a stall, but that's computed all by the RockM profiler trace. You basically just know when each instruction ran. You know when the instruction dispatched and when the instruction ran. And stall is just run minus dispatch minus the time it takes to run the instruction.
We don't know the time it takes to run the instruction.
No, we don't. My guess would be that there's profiles, that there's tables embedded in.
Yeah.
Yeah, I don't know. I don't think we have to use the raw one. This wasn't something I did during the week. This was just fun for the weekend. Yeah, it's kind of cute what the format is. It's all nibble based, so it's all 4-bit based, and then yeah, it like uses this like shift register. It's like very hardware. It looks very hardware. But yeah, so I got all the stuff decoding. If you're ever like confused about what's going on in the big profile, you can run this and actually take a look at what it's using to build that. Yeah, it also shows us how we might be able to like disable stuff to make the thing smaller or whatever. But no, overall, it's that RockM trace decoder, assuming it's stable, is giving us a lot of good stuff. I think we just hope they open source it.
Yeah, I don't know. It's quite hard with the callback pattern that they're using to like make stuff the incremental decoding. Yeah, right now
I'm,
like parsing the entire thing up front.
I'm not asking for stuff to be incremental. What I'm asking for is currently you're running the trace decode before Viz even starts. It shouldn't run the trace decode until I click on the kernel encounters.
But if you click away, I can't control C it.
That's okay, but
yeah, so for the control C, actually, the only way I found is using threading. So yeah, and that
using
works
what?
fine. Threading, like to put this RockM profile into a separate thread.
Oh, you put in a separate thread and you like pthread kill it? Yeah, cool. And that seems fine too. But
Yeah,
I'm
so
less
when you
worried.
wanna like start the decoding when you click on the counter thing.
Yes, because I'm less worried about the annoying thing now is like if there's 20 kernels and they're all kind of big, it takes 30 seconds to start Viz. We can never have that. Viz always needs to come up instantly and then can spend time decoding this stuff later. If you can't control C it, that's a limitation, but I think threading and pthread kill is pretty good too. Like it's better that you can't control C it when I click away than Viz takes a long time to start up.
Makes sense. Yeah.
And actually, I'll just say that we have separate SQTT profile events for different launches. So it should be pretty easy to parse the blobs you need.
Oh yeah,
Oh yeah,
I mean that's all.
after the kernel. Yeah.
Yeah, I looked at that. It's per kernel and it's per shader engine, so we can totally. I mean the format's incredible. Like it's logging literally 2 things for every instruction. I still don't exactly understand how to recover what the PC of the GPU is. I think you might actually just have to count them all. But like it doesn't tell you the PC. It logs nothing you don't need. They really made this format super minimal. And yeah, cool. Good progress. Hopefully we can start using this to debug and make our kernels faster. Oh, the one that I really want you to test this stuff on is AMD UOP matmul. It should be like decently fast and usable with AMD UOP matmul. You don't have to run the matmul 10 times.
Good. Yeah. It's a very big one. But
That's the scale we need to be targeting. I mean, it's not crazy big. It's a much smaller matmul than any of the Llama ones.
yeah, so we get every hit of the instruction. So it's gonna be like a couple. I'll test it.
Cool. Yeah, I mean, we can also there's SQTT lets you disable a lot of stuff. Like we can disable instructions, we can disable registers. Like the most important thing to first get is just literally wave start and wave end, and that's pretty small. So I don't know.
Oh, that's
Maybe we can
very small. Yeah.
Yeah, like maybe we can have an SQTT equals 1 and an SQTT equals 2, depending on what you want to say.
I actually have a prototype of instead of decoding the instructions array that the decoder gives us. Instead of like parsing into the array, which we right now do, we just copy the entire block into Python and then decode the instructions later, and that's very fast.
Cool.
Yeah.
But yeah, I want it to be usable and decently fast on AMD UART MapMol. Like if I was using this to iterate on that.
Sounds good.
Let's SQTT. We briefly touch on the flash attention, but Wolfsberry have anything to update?
Most of the stuff is good. I have a PR for some MI350 support in Tiny Kittens. The main thing we're missing right now is just shared memory swizzling for shared memory bank conflicts. A lot of the hip kitten stuff is a little annoying. I don't want to go to assembly, and a lot of their kernels go down to assembly in order to hit max perf. And I'm hoping that we can get some decent performance without having to do that. Oh, we'll see.
Yeah, I'm totally fine with it getting like 80%, as long as it's not 40%. Yeah, I mean, we can look if it's interesting what they uncovered, that depending on the size of the load, it determines how it accesses the banks. Just
Yeah.
I mean, that's crazy. Like, I don't, does LVM even like support stuff like that? I don't know if it does.
Yeah.
I've never heard of like a chip doing that. So I mean, you have to think about like what it is in their like memory dispatch that like, why does that affect what banks it can access? I don't really understand that. But yeah, regardless, no, I don't think we should have to go down to assembly. I think just make sure your memory patterns are exactly the same. But I mean, it'd be cool to get the real one building too as like a custom kernel, and then we can compare them in SKGT and stuff.
I did try that. The hip compiler is annoying to get working. I ran into a bunch of like include errors.
Yeah, I mean, I don't know. Their MapMol example didn't work. Their MapMol example, I think they tested things on 7.0, and then on 7.1 it broke. And it didn't break the compiler. It just started giving wrong answers, which is, I don't know. Maybe next weekend I'll try an assembly backend. We'll see how much progress I can make.
Do they have a secretly good Docker container to use?
AMD has a secretly good Docker container? Is that what they're saying?
Yeah, do they?
I don't know.
Okay.
No, I mean you just look at the way that MapMol is written, and like it doesn't look like the CUDA one. It's clear how it's not just performance impact; it's actually wrong. Which, yeah.
Okay.
I don't know. But also, the kittens people don't seem. They seem to be researchers. They seem just interested in achieving max perf on one. Works on my machine is good enough for them. So.
Okay. I mean, it's what it is. It's nice that there are people trying to get a max perf.
Yeah.
Okay. Other bounties. Do we get?
Want to talk about the AutoGen stuff?
Yeah, I mean, the AutoGen stuff has merged. It's kind of nice because we got to clean up a lot of the Objective-C stuff. there's still like one or two things that like are still have to do like the manual message send. But
what's the manual message send?
like you have to do obfusc underscore message sends for a couple string manipulation things because it uses the string manipulation in Objective C uses categories. I think they're called. I put a comment about this. Oh yeah,
Did you get that one? Yeah.
Yeah, I don't know what's up with that. Anyway, I wrote a patch that fixes it. It's not a problem with the real autogen because the real autogen generates stuff that looks like that rather than putting them inside the thing. I can try and figure out.
What do you mean the real autogen?
Like the script generates code that, or like the support / autogen generates code that looks like the thing I posted right there. Whereas the test was I put the fields inside.
Oh, I see what you're saying. So it's just the test. Oh, cool.
Yeah. Yeah. So it's not a real issue.
Yeah.
I mean, I could try and figure out exactly what's going on there because it should work, but. Yeah. So anyway, yeah, there's these Objective-C categories which we could try and parse as well, but it just seemed annoying and also like it's only used in like 3 places. So
just make the escape hatch code clean and
yeah. Yeah. I don't know if there's anything else with autogen right now. The nice thing is that you think you mentioned this last time, but it's easy to edit it now because it's just in tree and it's not like.
Yeah, no, that library was bad to rely on.
Yeah.
I mean, it was fine at the beginning, but it kind of got out of control.
Yeah.
No, it was sed script. The sed editing of the outputted thing really got out of control. Yeah. So cool. Well, that's done.
Yeah.
Other bounties. It looks like there's progress on the torch bounty. Which is good. I will relock that. Don't tell me that it was fast enough. I know how fast it used to be. It used to be good, so we got to make it good again. But yeah, looks like we'll get that back soon. What else we got?
There's some update on the Winogre one, it seems.
Is it ready to merge? Yeah, I pinged him about that. I went through all the pull requests. We should do the same for the issues, but yeah, we're.
No, so the issues, I went through that multiple times, and many times broken things are still broken.
Wait, so we really have 127 issues still?
I mean, probably like 20% of them might not be relevant or not true anymore, but a lot of the issue is true.
Yeah, we should start fixing issues. I mean, hopefully we're kind of in a place where it's I don't know. I just feel that like the deletion of shape tracker and the deletion of kernel.py puts us in a place where there's like not much more to delete. So we can start actually fixing issues. Like it's not like, oh, it's going to be fixed in the next rewrite. The only big rewrite I kind of see incoming is going to be things that like if we find ourselves tweaking symbolic because of rule order, that's just going to all be fixed with egraphs. Or anything that effectively looks like, oh, like we had to write this one rule to combine these 3 rules because it doesn't match right. Like this is all going to go away with egraphs. I mean, we have to do it. I mean, there's no way. Because like some guy posted, oh, there was an issue. There was an issue where someone thought like 2 things should be equal. Here, the expression equality bug. And like we need to fix this. Like there's those 2 expressions.
Isn't that one just the person didn't code simplify?
No. Well, yeah, part of the problem is they used equals equals and not equals, which is fine. They were using it wrong. But even if you use it right, it's still wrong. It still doesn't work. Like because of how the fact.
We don't have a lot of these. I don't think egraph can solve that. I don't know.
No, egraph can totally.
Polynomial canonicalization is a pretty hard problem.
What do you mean? But egraph can totally solve it. But this is trivial for egraph to solve.
It's a pretty hard problem.
Well, you don't solve it, but the egraph doesn't solve it with canonicalization.
Yeah, it's like a union find thing, right? Like
Yeah.
they just have the same representative.
Yeah. And if the two, and the egraph would do explicitly the look for equality. But also, why is
No, it's
polynomial? Why is this a hard problem?
oh, it's just very hard. Just imagine every variable you can have, how you add a sign to it, and you started trying to solve weird polynomial. Anyway,
Yeah, I mean,
so
like
the,
that.
the most generic form, it's a very hard problem. We probably don't need that. But then we
Yeah.
started to discuss like what do we use. Then we kind of settled previously on what's the real kernel that we encounter, and that's why we don't have all of these equality things expressed in rewriting rules.
Yeah. I don't know. I mean, I know things like this are very easy in egraphs. I'm not sure it's so easy to say that there's like a desirable canonical form.
Yeah, because previously we probably still use this in somewhere that we use this to find the strides for stuff, especially when your coefficient can be another variable.
I mean, that's not a polynomial anymore, right?
I mean, it's still a polynomial.
If your coefficient can be a variable?
Yeah, your coefficient is a variable, but it's like a variable from your shape and not your variable in your polynomial. Then in this case, do you rewrite or not? How can rewriting rules tell if it should flip these two or not?
Yeah. No, of course, yeah, you can't know
Yeah,
that.
so that's where we start to get like, do we include this flattening rules or not? Do we
But
sort
I mean,
this or not?
that thing is no longer a polynomial, right?
What do you mean? It's still polynomial. It's linear. It's a linear function.
It's not a linear function. I'm multiplying a variable by another variable.
Yeah, but in this context, you treat one variable as a constant. That's fixed when you
Yeah,
do the
but you
computation.
can't.
Anyway.
Yeah.
Yeah. I think these I don't know. I guess we would know if we really start to include egraph. We probably would know better.
Yeah. I don't know. I'll do scan this week, and then maybe next week I'll start looking into egraph. I mean, it's something we have to do, but it's very nice how I think we can very like comfortably transition to it. There's going to be it's all the same rewrite rules. It just sometime applies them more, and instead of giving you one output graph, it gives you a data structure which contains millions.
Oh, sounds good. Okay. I think Wolfsburg Lockle GPTOS is that true?
Oh yeah, we can lock GPT. What's the current speed on GPT-OSS?
I have no idea. Does it wrong? A single person is in the meeting.
I think it runs, but I think it's just that the speed isn't good, and like how far we 0.1 tokens per second. Okay, we're 1000x off. All right. Well, that's something. All right, I'll relock the torch backend based on that picture. But yeah, no, we do need it to not realize. If it's realizing at every torch thing, there's no point. It's got to still be kind of lazy.
So let's GPT OSS. Then we have this torch backend lock. GPT OSS also locked.
Yeah, I'll lock GPT-OSS, but why is the speed so bad? Not sure why it's so slow. Okay. Uh, I would pay out that bounty about proportional to the speed. So if at the end you get to 50 tokens per second, half the bounty. At 0.1 tokens per second, it's worth $1. Cool.
I think they're supposed to update on the Whisper.
I mean, there's always constant updates on the Whisper. I don't know. We just have to put something up that you want me to merge. You know, I don't need every update on this. Just like, oh, this is good. I want to merge it. Okay, cool. Yeah, we're gonna do HVAC. So I'll lock that one. Oh, USB 3.0. Don't believe we have a bounty for that. These bounties still look good. Oh, I'm deleting the HLB far torch bounty one. All I get is LLM crap for that. Same thing with the beautiful MNIST. Oh no, the beautiful MNIST torch one I'll leave because LLMs can't do that one. LLMs just misunderstand that one. The CFAR one they like understand and they give me something that's yeah. Just a reminder, I don't care if you use AI, but if you copy and paste from the AI something that you do not understand, you are wasting my time. And I think that we might start doing just GitHub bans if people do that. Like, because don't do that. Don't do that. Please don't do that. You want to use AI? Use AI. That's great. I use AI. Everyone loves AI. But if you're just copying and pasting something you don't understand, you're actually more useless than the AI. Right? Like I can do that too. I can also copy and paste things I don't understand from the AI. Right? What did you do here? Right? The point of people is to look at the AI and be like, wow, this thing's hallucinating garbage, which, you know, about half the time it is. But it was a lot of fun vibe reversing SQTT. GPT 5.1 is pretty good. It's the best reverse engineer I've seen in a model. So
Yeah, I think LLM is really good working on like translation or anything anytime you already have every context you need in your input prompt.
yeah, I mean, I can literally copy and paste the decompiled stuff from Ghidra into the LLM and be like, what does this do? And like, it would take me 30 minutes to read the function, and the LLM gives me an answer in 2 minutes. So it's great. That's pretty good. But yeah, it's translation basically. Yeah, that's why it's good. Yeah, all right, cool. Yeah, I think the HVAC code thing is quite important to us. Comma's not using a whole bunch of their GPUs because their current HVAC decoder uses tons of memory. So hopefully we can get to the bottom of that and not use all the memory. Yeah. Nimogen, anything we can do to make that easier?
No, I think.
Cool. Oh, there's still a bug also in timing with PM4.
I fixed it 2 days.
Oh, you fixed it? Wait.
Yeah.
This was happening yesterday.
Yeah, I fixed it 2 days.
Oh, you fixed it today. Okay, cool. Oh, here, AMD timer fix. What was it?
And it's pretty. I just read Mesa in details, and they just actually. They actually have like two. Like
they
two
call release
release
mem
mems.
twice?
Yeah, because actually, I don't know. I can't reproduce these on RDNA 3. Only on RDNA 4, but yeah, it's. But actually, on RDNA, they think that the full flush of after compute shader is to use the event write we do like in the exec and the release mem. So not the timer one. So I think that was the problem.
I see. Yeah, no, I mean I see how there's two release mems in the signal. Cool. I mean, yeah, it shouldn't be too slow. Should be fine. I don't know. Those names have always been weird to me. Release mem and acquire mem. Do they make sense to you?
Yeah. I mean, it's kind of like atomic ordering, so it's the same things.
Yeah, but what does acquire mem do?
So actually, like, it won't allow any packets reorder, like, which have bottom. Like, it's basically when you take lock, you have to function to acquire mem and to release mem,
Sure.
and you're not allowed to, like, to cross these boundaries. I mean, if you release mem, you don't
Yeah.
want to see that all the upper instructions happen
So
after this release mem.
Sure. Okay, that makes sense to me. Like
Yeah,
acquire
but,
mem is like acquiring a lock on the memory.
Yeah, it's a fence with acquire semantics, right?
Fence with acquire semantics.
Isn't that like a thing that people talk about with?
I believe it.
Okay.
But okay, all right, good. That's a simple way to think about it. I mean, it's just weird to me that you have to do two release mems, but if it works and Mesa does that, then yeah.
Yeah, because I think the timer one is a fake one, kind of.
Oh, I see. So you're saying that it's not actually doing it if you're doing the timer right. It's not actually doing the
Yeah.
normal release. Oh, okay. Acquire it. I see what you're saying. Yeah. I'm thinking back to operating systems class, and it's like a semaphore. You wanna acquire the mutex while you. I don't know what's this. It's like a.
Because it's not a lock, because you never release it, so you'd be like, right? You'd be totally fucked if you
Cool.
I think that's it for the schedule agenda. Anything else?
Nope. Yeah.
Okay.
End of the year, we're gonna be training Llama 8B. We're gonna have a Llama 405B that starts up fast, and we're gonna have decent gem and flash attention kernels written in UOPS running for the Llama 8B. And then just next year we gotta scale it up, debug a bunch of issues, and we should be good. But yeah, no, if we can get an 8B training by the end of the year, we're so on track. Especially if we can do it with scan and stuff.
Good.
Cool.
That's it for this meeting. Thanks everyone. Goodbye.